Welcome to week 4 of online learning. Make sure that you continue to submit your work each week. Our gradebooks are now open, so each day that you submit work, you will get a grade in the gradebook for the grades that you're doing. So what we are doing this week is finishing up exponential functions. So last week we talked about exponential functions and we talked about how it works with the coronavirus, with the COVID-19. And today we're going to continue to talk about exponential functions, but these are just normal functions without word problems here for this first video. So what is important, what you need to remember, is that an exponential function is a graph that looks like this. So this one here is a growth because it is increasing. In an exponential function, there's one point that matters significantly, and that point is my y-intercept. So my y-intercept is the ordered pair where this graph would show my initial value. So in this graph, my y-intercept is at 0, 1. And then the next ordered pair here is right 1, up 2, and then the next one here is right 2 and up 4. Okay, so this is a table that would go with this exponential function. You don't have to write this part down. This will just make it much easier to understand the actual numbers that you will write down here in a second. So what we have an exponential graph, and I just took its ordered pairs and I wrote those ordered pairs on the table. So what is super important about this formula is that we have a number in the front. So hopefully from last week, you remember that the number in front is the initial value or the starting number. That's also called a y-intercept. So my y-intercept is the number that sits in the front of my exponential function. Then the only other number that we need is the number inside the parentheses, which is called the multiplier. If it's bigger than 1, it's a growth function. If it's smaller than 1, like a fraction that's less than 1, it would be called a decay function. So that's growth versus decay. So when I look at this graph here, what I know is that my y-intercept would be y equals, the y-intercept is always the number behind a 0. So in this one, my initial or my starting number would be 1. So then from this table, I can see what it's multiplying by. So from 1 to 2, that is times 2. From 2 to 4, that's times 2. So that is my multiplier. And then we just raise this thing to the x. So that's what we're going to do today. We are going to write the equation of an exponential function by knowing that the starting number is my y-intercept. Y-intercept is always written as 0, number. That's the y-intercept. And then the b is the multiplier, so what it's being multiplied by. So let's look at number 1. So in number 1, I am writing an exponential function. So on your paper, I need for you to write 1, and then I need you to copy down this table. 0, 3, 1, 6, 2, 12, 3, 24. Okay, so to get this equation, I need two numbers. I need the a value, which is the y-intercept. Remember, a y-intercept is a number behind the 0. So in this one, my y-intercept is the number 3. Very easy. Next, I need my b number. My b number is the multiplier. That's what we're multiplying each thing by. So to get to from a 3 to a 6, they times 2. To get from 6 to 12, they times 2. To get from 12 to 24, they times 2. So that's my multiplier. They're multiplying times 2 in every one. And then we raise it to the x. Very easy. So now we're going to write down if it's a growth or a decay. To know that, we look at the b value. That's my multiplier. This is number 2. Multiplying by 2 would make this bigger, so it's called a growth. Okay? So go ahead and try number 2. I'm going to erase all of this extra stuff so it doesn't confuse you. So keeping it super simple, number 2, step 1, find the a, find the starting number. So y equals, the starting number, the initial value, is called the y-intercept. A y-intercept is a number behind 0. a number behind 0. Write down your y-intercept. Then figure out your multiplier. Your multiplier is what they're multiplying by in each number. And then raise it to the x. It's always raised to the x. Okay? Growth is your multiplier bigger than 1, or is your multiplier a fraction that's smaller than 1? Okay, try number 2. All right, let's take a look at number 3. So in number 3, same thing. We are writing the equation of an exponential function. This is from a table. So what we start with is my initial value, or my starting number, which is called the y-intercept. The y-intercept of this table is 4, because it's the y number that's behind a 0. Then my b is my multiplier. What is it multiplying by for each of these numbers? So if this one, it doesn't look like it's multiplying, they're getting smaller. These numbers are getting smaller and smaller and smaller. So to get from a 16 to a 4, that's like they divided by 4. But in math, dividing by 4 is the same as being a multiplier of 1 over 4. This is like saying we have 16 and we're dividing it by 4. So our multiplier is the number 1/4. It's being cut by 1/4. 4 times 1/4 is the number 1. 1 times 1/4 is 1/4. So in this one here, my multiplier is 1/4. Always raised to the x. So this function is a decay because my numbers are going down. They're getting smaller because this is a fraction. So this is a decay in number 3. Okay, go ahead, try number 4. So you have y equals. Find your initial value, your y-intercept. That's your a. And then figure out what's happening to get from a 24 to a 12. From that 12 to the 6, from 6 to 3, what is it decreasing by? What is your multiplier there? Very easy. Okay, so we're going to do the same thing with number 5. So in number 5, you do not need to draw this graph, but what I do want you to do for number 5 is let's turn this graph into a table. So what we have is, I don't care about these fractions on the left, those don't matter. I'm going to start with just the whole numbers. So on my table, my first ordered pair is 0, 1. Then I have 1, 2. Then I have 2, 4. Then I have 3, 8. Super easy. Okay, so from that graph, I just pulled off the ordered pairs that have whole numbers. So now I'm writing the equation. So when I write the equation, it's y equals. I start with my initial value. That's called the y-intercept. That's where I begin. So my initial value is 1. I could also look at that from the graph. There's that y-intercept. It's 1. Then I have a multiplier. I need to figure out what it's multiplying by. So you only look at the y values. When you're looking at the multiplier, it's just the y's. So to get from a 1 to a 2, they did times 2. From a 2 to a 4, times 2. From a 4 to an 8, times 2. So my multiplier is that it's multiplying times 2, raised to the x. So this function is a growth because the number in parentheses is bigger than 1. So this here is a growth. I also know it's a growth because the picture of the graph, it's going up. It's growing. So it's called a growth function. Okay, one more, try number 6. So on this video notes, your goal is that you can write the equation of an exponential function. So easy. To write the equation, you find the y-intercept, that's your a value. On a table, it's the number behind a 0. So find your y-intercept, put that in the front, and then find your multiplier. What was it multiplying by for each one? So number 6, very easy. Okay, that concludes our video notes 1 for week 4. So make sure you have written down numbers 1 through 6 and then submit week 4 into your assignments. Have a wonderful week. Go ahead and log in and look at week 4 video notes 2. Video notes 2 coming on up. Thank you.